Welcome back to another session on data structures and algorithms. So in the previous video, we have already seen how to transpose a matrix. But there was a problem over there. The space complexity was higher, that is big O of n square, because we created a completely new matrix in that case. But now let's discuss, without creating a new matrix, how can we actually reduce the space complexity and just do the transpose in the same matrix itself. So if you ask me how, it's very simple. You just have to observe few things in the particular matrix. So let's start observing those things in the particular matrix. So this is the matrix that we had seen earlier. Now I'll put all the rows and the columns, and now let's start seeing one thing. If I take the element 1, so that's present in 0, 0. Next, if I take the element 6, it is present in 0, 1. So it's present in 0, 1, but in the result it should what should be present? That should be 2 is what should be present. But where should 6 be present? It should be present in 1, 0, and that's what we had seen in previous video as well. At the same time, 6 goes to 1, 0, but whatever was there in 1, 0, where does it go? It actually comes to this place, that is 0, 1. So they are just swapping each other. Now let's see whether that's the same scenario in all the elements over here. So if I come to 11, 11 is actually present in 0, 2. So this element should actually go to 2, 0. 2, 0 is nothing but over here, and over here we have 3. And where should 3 go? 3 should actually go to, from 2, 0, it should go to 0, 2. And the same thing happens with 16, and the same thing happens with 21. And 16 actually swaps with 4 and 21 swaps with 5. And that is what should happen. Now if you observe over here, basically I need to do swapping for all these elements in this particular row and all the elements in this particular column. Now how can I do this? Very simple. I hope you already know how to swap two numbers. In case if you don't know how to swap two numbers, I'd suggest you to go and watch the video of swapping two numbers and then come back and watch this particular video, because swapping two numbers is one of the simplest problem in case of coding. Coming back over here. Now observe one thing. In the ith row, what is that I am swapping actually? I am actually starting the value of j not from 0, because if I swap 0, 0 with 0, 0, there is no swapping happening. The same element with the same element I am swapping, which is not necessary. So what I do is, value of I will start from 0, but see the value of j will start from actually 1. And what I am doing is, whatever is there in AR of ij, I will swap with, basically I am saying whatever is there in 0, 1, I am swapping with 1, 0. Next, I will increase the value of j. Then what I will do is, whatever is there in the element 0, 2, I will swap with 2, 0. Next, whatever is there in 0, 3, I will swap with 3, 0. Again, I will increase the value of j, it becomes 4. Whatever is there in 0, 4, I will swap with 4, 0. So basically, this is the operation what I am doing. And if you see, whatever is there in index I, j, I am swapping with j, I. So basically, I am doing the swapping operation between these two. And if you had seen, the value of I is 0 and the value of j goes from all the way from 1 to 4. Now let's see whether the same thing works out with when the value of I is 1, or I can say whenever in the second row as well. Do I need to implement the same thing? So if I go to the second row, what exactly does it happen? Let's see over here. So in the second row, if you observe, again I can't start from index 1 itself, because index 0. So I value I have increased. If I start over here, what exactly happens is, what is this element? This is 2, which is already swapped. So I should not swap again. In case if I swap 2, with whom should I swap? That is 1, 0. I need to swap with 0, 1. What is there? 6 is there. So the elements comes back to the same place. So I should not swap this element. Now should I swap 7? No, because 7 stays over there. Then what should I swap? Should I swap 12? Yes, because it's not swapped yet. So basically, I value I will start, whenever I value is 1, I will start the value of j from 12. From 2. Whenever the value of I is 1, I will start the value of j from 2. Next, see the element over here. The element over here is 12. So what is the index of 12? 12 is 1 and 2. 1, 2. So with whom should I swap? I need to swap with 2, 1. So that's nothing but 8. So 8 and 12 I need to swap. Next, again I will increase the value of j. I will swap this 17 with whom? I need to swap with 9. So that's nothing but 17 is present in 1 comma 3 and I need to swap 1 comma 3 with 3 comma 1, that's 9. Same way 1 comma 4 I need to swap with 4 comma 1, that's nothing but 10. 10 and 22 gets swapped. So now if you observe, whenever the value of I was 1, the value of j didn't start from 1, rather it started from 2 and went all the way till the last index. So I hope you are seeing certain kind of difference over here. Next, if you ask me what is that I need to do, very simple. Let's go to the another row. So I will actually bring the row to next row. So from 1 I will bring to 2. In this particular row, 3 which is already swapped. So basically 3 I had to swap with what? 2 comma 0. 2 comma 0 I had to swap with 0 comma 2. That's 11. That is what we swapped in the previous case. We have swapped 8 as well and 13 we don't have to swap. So from where do I need to start? I need to swap 15 and 23. With whom should I swap? 14 and 15. So basically 15 is present in 2 comma 3. I need to swap with 3 comma 2, that's 14, and the 23 is actually present in 2 comma 4, that I need to swap with actually 4 comma 2, that's nothing but 15. So these indexes you will have to actually think and see properly. Once you start observing these things, the problem becomes very simple. So only 2 swaps is what I am doing. So basically when the value of I is 2, I am starting the value of j from 3. So that's the difference that is happening over here. Next, let's go to the next row. So if I go to the next row, what exactly happens? If I take you to the next row, if I see the row number is 3. Now 4 is already swapped, 9 is already swapped, 14 is already swapped, 17 is already swapped. Next what I need to swap? 24 with 20. That's the only element left out to swap. And if I swap this, the whole matrix will be swapped. So basically if you see, I just wanted you to observe that always we are swapping AR of ij with AR of ji. That is what has been we have been doing all this while. But I just wanted you to observe how the looping happens. Looping happens basically the value of I over here was actually starting from what? It was starting from 0 and it goes all the way till 3. It doesn't go to 4 because if you go to 4, only one element is left out. And the value of j, see, when the value of I is 0, value of j started from where? 1. When the value of I is 1, value of j started from 2. When the value of I is 2, value of j started from 3. When the value of I is 3, the value of j started from 4. This is the thing that you had to see. So basically what are we doing? We are just swapping AR of ij with AR of ji. Now when are you swapping? Let's assume the I value is constant. So when the I value is constant, let's take this particular case. The value of j, when the value of I is 0, from where is the value of j starting? I plus 1 is starting and going all the way to the last index. So what is that I need to do? I need to repeat this operation for a loop. Which loop? For one row if I have to do, I need to write one for loop. So I'll say for the value of j always starts from I plus 1 and goes all the way till the last index. Every time it goes till the last index. You can see in every cases. So I'll say it starts from I plus 1 and goes to length of AR. Next, after this, what is that I need to do? Very simple. Now this particular thing will just take care whenever the value of I is 0. Now I need to do the same thing for all the value of I from 0 till length minus 1 because it's not going to the last index. So that's what I will do. The same operation I will repeat again and again. So I'll say one more for loop and I'll say I is equal to 0 and goes all the way till length of AR minus 1. So this is the logic for swapping for transposing the particular matrix within the matrix itself without creating a new array. So I hope this particular logic is completely clear to you guys. I just want you guys to just implement this and see whether it's working for you or not. So in case if it is, it will definitely work for you. Now you might be thinking, what happens in case if I write the loop normally rather than writing it like this, like how you had written earlier. If you do it like earlier, what happens is in all the elements swapping happens 2 times. If it happens 2 times, then all the elements will come back to the same position. First you will swap 6 and 2, again you will swap it back to 2 and 6, means the original position. So to avoid that, you need to write the loop in this particular fashion. Now let's go and write the code. Now let's write the code for the algorithm that we have already seen. So I have taken the same example. So over here I would like to do few changes. So what exactly I am doing is, I am not calling this transpose of array, rather I will create one more method named as transpose 2. I will name it as transpose 2 over here. Okay, and that doesn't return anything because I am doing the changes in the same array itself. So I will just remove this result. This part I will be removing. Next, this system.out.println. After that, I am printing the same array because the changes has been done in the same array. So I'll say AR. Great. Now transpose 2 has not been created. So let me go on top and start creating transpose 2. I'll go on top. Okay, fine. So I'll say static. And this method doesn't return anything. So I'll just write void. Okay. Static, then I'll say void and transpose 2. Transpose 2 is the name of the method. So it's accepting one two-dimensional matrix, so it's of integer type. So the same thing I'll be writing, integer type two-dimensional matrix, and I'll name it as AR. Now when I come inside this, now I don't have to create a new array or something. All that I need to do is just implement these 3 lines of code. So let's implement that. So I'll need to write one for loop. So I'll say for I int I is equal to 0, I is less than AR dot length. Now you don't have to go till the last row. That's the reason I need to write it as AR dot length minus 1. Even though if you go to the last row, it doesn't create any problem, but it's suggested that you optimize and always write it. Next, I will say I plus plus. Next, I will come to next line. Next, over here I will say int j is equal to, for int j is equal to, now I should not write 0. If I write 0, what happens is, rather than getting the transpose, I will get the same thing because swapping happens 2 times. So I will make this as int j is equal to I plus 1. Next, j is less than AR dot length, because always the value of j is going till the last. Next, j always increases by 1, so I will say j plus plus. Next, I will come inside this, and all that I need to do is swap AR of ij with ji. So I will just make use of temporary variable and swap. So since the values present inside this particular matrix is of type integer, so I will create a temporary variable of type integer. So I will say int temp is equal to whatever is there in AR of ij. Next, inside AR of ij, what I will do is, whatever is there in AR of ji, I will place inside AR of ij. How would I do that? I will say AR of ij is equal to ij is equal to AR of ji. So now basically whatever was there in AR of ji has come to AR of ij. Now what should come to ji is nothing but whatever is there in temp. So what I will do is, I will say AR of ji is equal to whatever is there in temp. So that is what I will place. So over here the swapping has happened. I hope you guys already know this swapping logic, which is very simple. So now let's execute and see if we are getting the expected output or not. So if I just execute this particular code, you can clearly see we are getting the expected output. Over here it's 1 2 3 4 5 and it has become 1 2 3 4 5. It's 6 7 8 9 10 and it has become 6 7 8 9 10 and goes on with the other rows as well. So this is how we can actually transpose the matrix within the same array itself, and we are actually reducing the space complexity. So whenever you go to any product based companies interviews, what they usually do is, they will ask you to write the code, and once you write the code, they will say some changes to be done in the code. And what are the changes? These are the kind of changes that they say you to do in the particular code. So in case if you are not even able to write the code, you should at least be able to explain the logic behind this particular thing. So how can you explain the logic? First thing is, you need to observe the particular input and take so much of information from the input itself. Only then you can come with the logic. I hope it's completely clear to you guys. Now whatever this transpose I have done, this transpose has been done for a matrix which is actually n into n, or a square matrix. Now I want you to try transposing a matrix which is not a square matrix, maybe which is n into m. So maybe that you won't be able to do in the same matrix. You'll have to completely create a new matrix and then do it. But how to do it? The logic whichever we wrote previously works the same way. But one small change happens. What is that small change if you ask me? While creating an array there is a small change. I want you guys to think on it and then do that particular program.